Guys, and welcome back. So this is Unit 1, Day 10, Writing Explicit Functions, and we are going to be doing this from geometric sequences today instead. So our objective is that we will be able to write an explicit function for a geometric sequence given the first term, so making sure we have the first term. So we are actually going to skip this first piece. We will do that in class, but we will do these notes on the back. So remember, an explicit function is a function that defines any term in a sequence. It will either state the zero term or another term with the corresponding term number. And it will also have the change. So we talked about recursives, and we've been talking about recursives. It's the same, but explicits now we have to deal with repeated multiplication instead of repeated addition. So let's look at this table here. So I'm going to just plug my sequence into my table. So f of n, for my first term I have 5, my second term I have 10, my third term is 20, my fourth term is 40, and my fifth term is 80. Then I'm going to expand it out. So remember, the expanded piece was writing it recursively. So I didn't do anything to get to 5, so I just put 5 there. But then to get to 10, I did 5, and then I multiplied it by 2. And then to get to 20, I took my 5 times 2, and I multiplied it by 2 again. And to get to 40, I took my 5 times 2 times 2, and I multiplied by 2 once again. And then to get to 80, I did my 5 times 2 times 2 times 2 and multiplied it by 2 again. So I could see that I just was adding another, or not, multiplying by another 2 each time. So before we get to simplify, let's go and let's write our recursive. So we found that we are multiplying by 2 because our R value is 2. Remember, R is equal to the second term divided by the first term, which gives us the 2 if you're having trouble seeing that. So my recursive function is f of n is equal to f of n minus 1 multiplied by 2 with a first term equal to 5. So now I'm going to go back and I'm going to simplify my, my expanded piece here. So remember that when you multiply something by itself, that's the same as squaring it. So this could simplify to be 5 times 2 squared. And that, I don't like writing it that way because look how that looks like 5.2. So instead, I'm going to write it as 5 and then put my 2 in parentheses and square it. And then 2 times 2 times 2 would be the same as 5 times 2 cubed. And 2 times 2 times 2 times 2 is the same as 5 times 2 to the 4th. So I can see that they're taking on this shell, right? So I want to use that same shell up here. So for the second term, I would have 5 times 2, and there's only 1 2. So I'm going to raise it to the 1. And in this first row, I have no 2. So I'm going to write 5 times 2 to the 0 because I don't have any 2's. And 2 to 0 is 1, which you may have learned last year in middle school. So now when I'm looking at that simplified piece, I'm seeing that all of my rows have 5s. All of my rows have a times 2. But the thing that's changing is my exponents. That's the piece that's varying. Since it's the piece that's varying, I want to relate it back to my variable, just like we did when we wrote our explicits for arithmetic sequences. So I know that my explicit function is going to start with a 5, and that 5 is going to be multiplied by 2 because that's what's the same and constant in each of my rows. But now I want to relate, how do I get from 5, how can I plug in 5 and end up with 4? How can I plug in 4 and end up with 3? How can I plug in 3 and end up with 2? So I'm plugging my n value into my explicit equation and getting this out for these specific terms. And if you've noticed, 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. So I'm just taking my n value and minusing 1 to get to the simplified piece. So for f of n, I would have 5 times 2, and I would just do n minus 1. So that is my explicit function. We can check that by finding the sixth term. And if I plug into here, I would have 5 times 2 to the 6 minus 1, which would be 5 times 2 to the 5th, which matches in line of what comes next after the 5th term. So 2 to the 5th is 32. So I'm going to do 5 times 32 to get my answer, which will be 160. And 80 times 2 is 160, so we know that we've done that correctly. Let's do the second one. So I'm going to plug in my points here. So we have negative 5, negative 10, negative 20, negative 40, and then I don't have another term there. So let's find our R value. So to find R, remember you do negative 10 divided by negative 5. Negative divided by a negative is a positive. 10 divided by 5 is 2. So we get positive 2. So we can go ahead and write our recursive. F of n is equal to f of n minus 1 times 2, with f of 1 equal to negative 5. And then we'll use that to write out our expanded piece. So remember, we didn't do anything to get to negative 5, so we leave it as negative 5. Then to get to negative 10, we did negative 5, and we multiplied it by 2. To get to 20, we did negative 5 times 2, and then we multiplied it by 2. To get to 40, we did negative 5 times 2 times 2, and we multiplied that by 2. We can find the next one, but let's see if we can figure it out from here. So when I look at all of my rows, I see that they all have a negative 5. So I'm going to go ahead and write that in my simplified piece. And then I see that they're all being multiplied by 2. So I'm going to go ahead and write that in my piece, in my simplified piece. And now I'm just going to count them up. I have 3 2s. So 2 times 2 times 2 is the same as 2 to the 3rd. And 2 times 2 is the same as 2 to the 2nd. 2 is just 2 to the 1, and no 2's is 0 2's. Once again, I see that this piece here is all constant. It stays the same for all of the rows. And the piece that's varying is the exponent. Since the exponent is varying, I want to relate it to my variable. So now I'm trying to figure out how do I write it for the f of n term. So I want to be able to plug n into my explicit and get out my answer. So if I just put an n up here, that would mean that I would plug in 4 for n, and that would be right here in the exponent. But it's not. 4 is here, and it comes out as 3. So in order to get it down to 3, I know that I need to subtract 1, so my exponent should be n minus 1. So if I wanted to do the 5th term, then it would be negative 5 times 2 to the 5 minus 1, which would be negative 5 times 2 to the 4, which makes sense because there were 3 2's here, and I would have negative 5 times 2 times 2 times 2, and then I would do another 2 to give me 4 2's. So my explicit function is f of n is equal to negative 5 times 2 to the n minus 1. We will do more examples like this tomorrow in class. So be sure to come ready with questions if you have them, and I will be sure to answer them. I will see you then.